Now starting. All attendees are in listen-only mode.
All right, welcome to today's Novedge webinar. Thanks for joining us today. I'm going to let you settle in, and we'll start about 11 a.m. Pacific time. So we still have a few minutes for people that are running and cutting, this time for a webinar to join us. And I just want to remind you that you can ask questions at the end of the presentation. So be ready, because this is your chance to have great live interaction with Edwin Braun. And who better than Edwin to answer all your questions? So this is a great chance for everybody. I want to show you that if you look on the control panel, there's a question tab. You can open it and type in your questions, comments at any time in the presentation, and there most likely will be addressed at the end. And you can also check in right now, say hi, let us know where you're watching from. It's a gorgeous day today, hopefully anywhere you're watching as well. It is here in the Bay Area, and it is unusual, so very exciting. Yeah, so last chance to get a last minute drink and snack, and then we'll start the recording, so stick around. And I also want to remind everybody that we will be recording this presentation, and you can watch it again after the fact on our YouTube or Vimeo channel. Just search for Novedge, and I will post it right, before the night. Okay, so it's right around 1 minute to go. Let's give people a chance to rush to their laptop, device, phone, or whatever, tablet to connect with us, and then we'll start, hopefully on time, because I know this is a precious time that you save on Wednesday morning, and we don't want to make anybody late, and want everybody to have a chance to be at the right place at the right time. Okay, so Edwin, it's 11 a.m. on the clock, and if that's okay, I will start my intro, and then we'll get the show on the road. What do you say?
Yep, go ahead.
All right.
I'm ready.
Start the recording right now. Bullet and more. In fact, there's a lot of things you don't want to miss in today's presentation that will be run directly by Edwin Braun, co-founder and CEO of Cebas Visual Technology. And Edwin heads the development team for thinkingParticles and the render software, and manages the North American Cebas office. He has dealt with visual effects program codes since 1988. Edwin spends his free time exploring VR and console games, coaches baseball, gardens, and enjoys photography. And welcome aboard, Edwin. Really great having you today, demoing thinkingParticles. And now let me tell you a little bit about Novedge. Novedge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service, and most importantly, no headaches. Check us out at novedge.com, and as you can see, this is the page where you can easily access to thinkingParticles 6.8 for 3ds Max. And also, let me remind you that we're all over social media, so for news and latest promotion, you can find us on Facebook, Twitter, Instagram, you name it. I also want to remind you that this webinar is free and is being recorded. So if you want to rewatch it, you can go on our YouTube or Vimeo channel later today. And now I'll share Edwin's screen and pass the baton to him.
Okay, good. Let me just adjust this, and you should see in a few seconds or in a second my screen.
Yeah, beautiful.
Okay, here we go. First, I welcome everyone to this live webinar. I'm Edwin Braun of Cebas Visual Technology, and we're going to have some fun with Thinking Particles and our latest release of Thinking Particles, our visual effects system for 3D Studio Max. And we are going to do something interesting, and everything will be live and done from scratch. So the experience you will have is kind of similar to an experience when you start doing visual effects. So things will get weird, we will make errors, we will try to find out what's going wrong and how we do adjust for the errors, or how things are connected to all these setups we are going to create. But before we do so, let's pick a scene we want to work on. And because I'm lazy and I don't want to model everything on my own, my first approach is just go online. And let me just go online and let's have a look. So I picked this scene from the internet. 3D models you can download there. There's free models. You can go everywhere on the web right now to grab some 3D models. So I like that model because for what we are going to do is we want to have these water mill going, water splashing down and all this kind of stuff. So we want to do the visual effects for that. And the cool thing for that model was it was available as a Max model, pretty decent in size. So we just download it and let's have a look at the model. Because as you might know, 3D models from the web, they kind of work or don't work, but most of the time you have to do a little bit extra work on those models. So what I did is I downloaded the model. Let me just load in the raw model. So that's what we got from the internet. And we're now going to see what we can do with that. But before we have and analyze the model, let me just show you what we are going to create. So let me just bring up here this little preview animation or animation I did there. So we are going to do this kind of animation and see how we can set up this animation here. So we will create the fluid simulation, we will create the rigid body dynamics or interaction, and we will use our latest OpenVDB boundary for the water wheel to work with the fluid together. And we will explore a lot of features and setups we have to consider when doing this kind of visual effects. Okay, so as I said, I downloaded the model from the internet so that we don't have to do everything on our own. The first thing we will realize or see is it's all one group. So if we select one thing, we select everything, so which is not really what I want, but let's just first explore a little bit. So I like the model. We have a little bit of the usual tricks in there with these transparent planes here, textures simulating water. We have this water flowing down, simulating. So these are all sprites or planes with textures projected on there. So we don't need that. So the first step you would usually do is you have to work on your model and extract all the important parts we care about our visual effects. So I'm just going to show you a little bit how you would approach this. I'm not going into too much detail, but let's have the usual pitfalls, the usual problems you would see in this kind of stuff. So the first thing I would do is just ungroup everything so that I have access to the stuff. Then what we want to do is we want to get rid of these sprites or planes that are not real visual effects, so they are just projected planes with a texture on it, and we can see, okay, we have here everything looks pretty good, but for extracting the stuff we are interested in, I'm going to pick the objects I'm interested in. So I get the water wheel, I get this thing here, and then what we would do is we would just hide the unselected stuff. So we extracted just the water wheel here. So now we end up with the water wheel, and it looks pretty good. So we have these separate objects. So for our visual effect, we want to have the water wheel moving. We would need to attach all these objects and then try it. And I did that, and when I did my first test with the visual effects here, I saw an issue with this 3D model. Don't know if you see that as well. We have this weird gap, and as you can see, this gap here kind of doesn't make sense to me. I don't know if it was intentionally or if anyone actually cares, because when you just have this as a still image, it doesn't matter if there's a gap. However, if you want to simulate fluid running down and getting catched in this container here, and then it's a problem because we will lose all our fluid through these gaps here. And I don't want that, because I want to create some pressure here so that the weight of the fluid is pushing down and moving the wheel. So what we need to do is we need to fix our mesh here. And we need to fix it in a way that the pedals here, or this wood part here, is actually connecting properly to the side so that we can pour in fluid and have some pressure on the wheel so that the wheel moves. So I did that work, I did adjustments, and the next thing that is also very important and that we always see with files you download from the net is that they don't care at all about pivot points or objects, how they are aligned or normals and all this crazy stuff. So it's always a kind of a little bit of a adventure getting scenes from the net. So as you can see here, our center of mass or pivot point is up here, which totally doesn't make sense at all. It should be in the center of the object. So when I press now center to object, we are getting somewhere the pivot in the center of the object, which is where we need it actually. So we need the pivot point in the center of the object. So why do you need the pivot point in the center of object? So as I said, we are going to do this visual effect where we have physics working, where we have fluids, we have weight of fluid, and we have momentum, rotational momentum, and all this kind of crazy physics going on. So that means our object has to be clean. It needs to work. So if our object doesn't work on its own, let me just go in here and rotate, we will have an issue. So right now, as you can see, all things are going crazy. Oh, let me just affect pivot point. So what we want to have is that our object is clean, and I mean really clean. It needs to rotate around its center of mass, And then we can be sure that all is fine. And we need to make sure that all our parts are working properly. Let me just select the inner part, and same deal here. Our pivot point for the inner part is wrong. So as you can see, we have to do some footwork before we can dive into having fun with visual effects. So everything has to be clean and working. And as I said, I already cleaned up the model. So we are going to have our, which I call step 1, obviously. So we're starting now with the cleaned out object. So pivot points, orientations are all fine. So we start out now with our clean object here. And also you can see I already have selections or groups. I have the landscape group, I have a pond. I put in here that we can use later. And let me just concentrate for this session on the physics effects or the visual effects for the fluid simulation and the water wheel. So what I'm going to do is I'll hide the landscape for now and do the same for the building. So right now we end up with the water wheel again. So what do we want to do? We need to create particles, fluid particles, and those particles need to interact with our water wheel, and we need to simulate the effect of water pushing against this wheel. So how do we start? There's several methods or things we can start doing our visual effects. We can do the chaos way or chaotic way. We just start whatever comes to our mind, we start with it. Or we prepare in our mind all the components, and when we have all our components ready, we go into thinking particles. So I kind of want to do a mixed approach here. So let's do a mixed approach. So I know we need to have particles at one point running down the chute here and dropping or pushing on the water wheel. So what we need for sure is an emitter for our particles. So I'm going to create a dummy object. A dummy object is the easiest way. Let me just select our object here and center it in, center it in all viewports. So the easiest way to create an emitter would be just with the help of a dummy object. So I'm going to create a dummy object right about here. And I'll just make sure that our dummy sits right where I want the emitters, or the emitter for the fluid. And I'll also rotate my dummy already along this water pipe here. So what we have now is our emitter dummy. So in theory, we should have now everything we need. We have a position where we want to emit particles. We decide on how and all the physical parameters, we decide on that. We have our water wheel, we have the pipe where the water runs down. So I think we have all the components we want now for our first step and approach to the visual effect. So now we have all the components, and we are going now to create our particle system, our thinking particles system. So we're going here, and the first thing is I'm just creating this thinking particles helper. And the Thinking Particles helper, we can click it anywhere we want. It doesn't matter. It's just a helper. This is just meant to store all our settings of Thinking Particles we have here. So the next thing is we bring up our Thinking Particles user interface. And let me just move that over here so that we see everything. So when I start with setting up visual effects in Thinking Particles, I usually create a base system or a basic setup that usually works for all visual effects. So the first thing is we need to decide on the particle groups. Particle groups are important, and the particle groups help us to control where and what particles are affected and how they are affected. So I'm going to create several particle groups, and I'm going to name them properly. So for sure, we need one particle group called fluid. We need another particle group called emitter. So I'll name that emitter. And we need a particle group where our something happens to our water wheel. So I call this, make it easy, wheel. So I think we can get away with these particle groups. Keep in mind, we don't have to know everything in the beginning. We can create particle groups. We can nest groups under each other and do all kinds of adjustments. We can drag and drop groups. So there's no need to know everything right from the start. But from the feeling here, we just have the fluids, for sure, an emitter, and the wheel. I'm pretty sure that's all we need right now we want to create for our visual effect. So now that I have created all my particle groups, my next step is to create my what we call dynamic sets. That's kind of my workflow node system, node setup, where we wire up our visual effects. So I'll create a few of them as well. And I like to organize them in a create dynamic set. So in that dynamic set, I want to put everything in there that creates things, gets meshes or objects into thinking particles, creates particles, and so on. Pretty self-explanatory. Then we need a dynamic set, an extra dynamic sets, gravity. I always like to have an extra dynamic set called gravity because I put everything that has to do with forces and things in there. It's just to stay organized and I know, okay, if something is affected like wind or any kind of external force, I'll put in my gravity dynamic set. And next thing is our simulation. So in that dynamic set, I will put everything that has to do with our fluid simulation. And then we have our last dynamic set, I think, for this setup. And I'll just call that OpenVDB. It's not specifically only OpenVDB, but I'll just call it. And the OpenVDB I will explain later when we dive into our physics effects here. So let's start with the create group, because right now we just have empty groups, no setup, no logic in there. So the first you always start is with creating stuff or getting meshes into thinking particles. So what we will do here is we will just go into our operators and go into generator, because we want to generate something, create something. And the first thing we create is we want to create our fluid particles. For that to happen, we need to bring in our emitter particle. And I'll explain in a second what that means. So to bring in things into thinking particles, we use the object to particle. Actually, the object to particle is my favorite operator or my favorite node because it is so powerful and lets you organize all the stuff and things in one go. So what I want to do is now get our emitter particle. So I'll pick our dummy. I'll make sure I only pick the dummy. The hit algorithm in 3D Studio Max has hit both. That's no problem at all. We can just go here and just remove selected. So I only want the dummy object, and I know the dummy is our emitter. So I'll make sure this dummy goes into the emitter particle group. And that's actually all I need to do. Our first object is in there. We have created our first particle, and this particle goes into the emitter group. Let me just go back and forth. You will see me going back and forth on the timeline for some time. We have various modes, but I just want to explain here with going back and forth, we are actually starting the simulation. So as long as we're not moving the time slider, no simulation is happening, so we can set up the most complex stuff. We don't have to worry. By going back to frame 0, we are starting the simulation again of Thinking Particles, and it will do all the simulations. Thinking Particles is a visual effects system that is always procedural and always simulating. So you will always get a simulated result of all you set up and of all your procedural nodes. So to prove my point, we can go to the emitter. I'll select the emitter group, and we will see we have a total of 1 particle. In our selected group, we have 1 particle. So this is how you can evaluate or change or debug that things are working. We brought in 1 dummy object. So we have this 1 dummy object, and it creates 1 particle and it lands in our emitter. So that's the first step we have. We brought in our dummy object, but this doesn't create any particles right now. This dummy object, let me just select that. So this dummy object is nice and cool, yes, but it doesn't create any particles. So the next step is we need to create particles. So we brought in a dummy object, and we just get the position of the dummy and the rotation and all the stuff that is attached to an object. We put that on a particle. So everything works with particles and Thinking Particles. So that's the power of our procedural system. So what we need to do now is create the actual fluid system. And for that, I'll use the flow emitter. And the flow emitter, all the flow emitter needs is a particle to create, at the position of this particle, to create an emitter. And I'll just grab that from our emitter particle group, and I'll feed in the particle. So what we did here now is we feed in the particle, or particles. It doesn't have to be 1. That's a cool and amazing procedural approach of Thinking Particles. I'll feed in the particle group into the flow emitters. We can have 1 emitter, or we can have thousands of emitters. We just have to put in more particles here. We can create them procedurally with other nodes, or we can just place them with dummy objects. So I'll feed in the dummy object, or the particle of the dummy object, flow emitter. Now the next step is, what do we want to do? We want to create our fluid particles, and the fluid particles should go into the fluid group. And I want to have the raster because I like that more, and I want to have the size of 25, and also the particles should have a speed so that particles move when they are created. Then let me just make sure we set the raster to this, and that's all we do for now. So let me just repeat again. We have a size of our emitter, we have a speed, and we have the raster size. So I think we're fine to go. Let's have a look what we created here. Let me just move that to the side and go to the other viewport. And as I said, right now, nothing happened because we didn't restart the simulation. Let me restart the simulation, and you see instantly we have our particle emitter here. So the main problem is, as always, let me just move the viewport here. The particles are moving not where I want them to move, because I want them to shoot out already in the right direction. So it's like an overflow from this little pond we have there. So they should go in this direction, not up. So something is off or something is wrong with our setup. And we can see, yes, the particles are going up. And this is what usually happens when you start setting up your scenes. Let me just move that over here. So what I want to do is actually, and here comes the cool thing, because we have a true, always procedural simulation system. This always procedural simulation system in 3D Studio Max allows you to adjust everything at any time, and it's up to you. You can decide. And the cool thing is, I'm going to rotate now the dummy object, and I'll just roughly align it along with our pipe. So I did the rotation. I'll go back to frame 0, and you'll see instantly it updates the simulation, and now we have the particles going in the right direction. So I didn't have to adjust my setup here in thinkingParticles because I'm working fully procedural. So we bring in the dummy object, put it as a particle in the emitter group. The particle inherits the position of the dummy, the orientation of the dummy, and all the parameters the dummy has. So that's why I just have to adjust the dummy, and the rest will always resimulate, always do whatever needs to be done. So now we have our proper simulation here. Our fluid is flowing in the right direction. So we're fine and we're ready to go. Let me just move that here so we see our fluid is now flowing. So that's cool, not bad for now. But I know when we're talking about physics and fluid simulations, we have to add some physics parameters. And what I'm doing now is when we create these flow or fluid particles, so when they are created the first time, I want to assign some physics properties. So I'll go into my standard settings and assign a mass to these particles. Because without a proper mass, we can forget any kind of physics simulation. So we need to assign a proper mass. And keep in mind, when we are doing a fluid simulation, it means every particle, every water molecule has a mass. So I'm setting this to a pretty low, small value here of 0.1. And that's just the only thing that really matters is not having a real mass. The thing that really matters is that the relative distances between objects, that they are realistic. So I'll set it to a 0.0 value. Then let's clean a little bit our viewport. So we have everything right now. We have a mass, and still the animation doesn't look different at all because we have no gravity. As I said, we would like to have the gravity affect our fluid, because like in the real world, water falls down and not up, or it doesn't float in midair. So we need to add some forces. So in the force section, we see our standard force. And here again, the procedural approach is so easy and so effective. We just decide here our fluid particles should receive the force. And we are in centimeters, so we need to make sure that we are properly scaling our force to 9.8 meters per second. And that's actually it. Once more, we restart our simulation, play back our simulation, and here we go. Yay, we have our simulation here and particles falling down. So the one thing we don't, for sure, we don't like is that the particles are falling down through our pipe. We want that the water is running down the pipe based on the gravity and then falling onto the wheel. So how can we achieve that? That would be the next step. We need to turn these particles, which are right now just dumb particles, they're born and that's it. We need to turn these particles into a fluid. And once more, we are going into our simulation dynamic set. I want to have everything clean so that we know what's happening, what kind of steps we have here. So let's turn these particles into a fluid. For that, I'll go into our flow section. And now, the important part is the order you create your fluid setup. So the first thing is I want the flow group. Then I want to have a boundary. So that's the next step. And then the most important is we need a flow solver, because without a flow solver, nothing is working. So I visually arrange these nodes in the order they should work, or the order they have to be so that it works. But as you know, this is just like a graphics system. I can place them wherever I want. So it doesn't matter how I place them on my work paper. However, I always like to have my order of the nodes in the order in the tree view. So when we go over here in the tree view, I see the first thing is flow group, the second node is the boundary, and the third is flow solver. This order is very important because this order allows you to decide which node is calculated first. So the flow solver has always, or needs to be always, the last one in the row of a fluid simulation. So make sure the flow solver is last. That allows us to have proper interaction with the flow group. So now let's set up the flow group. What we do is pretty simple. We decide which is the flow solver we want to use, this one. We could name this flow solver to anything we want, but for now I just keep it flow solver. And then we need to decide which particles should become a fluid, and obviously we want to pick our fluid particles. So now we have our fluid particles, they will become a fluid, and now we need to adjust the parameters we want to have, and I'll just start with a rough base of settings with our fluid solver, and then we already have a pretty good basic setup there. The next thing we want to do is the same for the flow boundary. We need to decide, okay, this is the flow solver handling our fluid simulation. And then we need to add our actual boundary. So I told you there's several options we can work now here. I'm going the lazy route, so I just pick the object. I like to pick the options. However, we can also feed in particles to act as our boundary. So we could have brought in the pipe as a particle and then feed in the particle in here, where we feed in the group of particles, or choose the particle group here. So that's also possible. But as I said, I'm lazy, so I like to pick just here the pipe, and that's it. So the next thing I want is it's unyielding, so this thing shouldn't move. The particles should bounce off and flow down. And that's actually it. We might want to adjust a little bit our bias for collision control. for collision detection. And that's it, we're pretty done. So if we go back now and start to simulate again, we should actually see a fluid. And this is what's happening. So now our particles are no longer falling through, as we can see. And we can see on our pressure display, we actually have a fluid and not just particles falling down. So we created our first fluid simulation. Just with 3 operators and a simple setup to get our basics in here, so the fluid particles, and we have our fluid going. So I would be bold and say there is actually nothing on the market that gives you in 3D Studio Max this fast fluids, this easy setup, and still fully procedural. So we can still work on it and can modify the heck out of it. So let's have a look what's happening here. So when we look at the thing, we're actually missing our container where we want to actually fill in the water. So there's a reason for it. We have real world gravity. So our particles receive a good amount of acceleration. And let me just go back here. Our flow emitter also adds already some speed to it. So if we look from the side, we see the particles already have a little bit of speed, which means they're coming out here. And that's also fine because we have some pressure from our pond that feeds our particles. So we could increase the speed we emit the particles, and then we would have here a high pressure coming out. And that wouldn't help us. So what I'm doing here is even worsening our setup, because remember we wanted to have the fluid interact with our wheel, and we want to fill the chamber here, the little container here, and that way it should move our water wheel. So that really doesn't help us. I'll keep it at 10. So just so that you know, let me just bring that back in. So to a value of 10, that means when we simulate again, we just have a little bit of forward momentum for the fluid coming out of our emitter. Then gravity kicks in, and the rest is actually just the gravity plus the initial velocity the particles have. So what we need is also a real world thing, because in our boundary, if we have a look at the boundary, we have physical parameters like friction, bounce, buoyancy, and adhesion. So they are all right now set at 1, and this is how it should be there, because the boundary is acting or can act for multiple objects or multiple fluids or particles. So where we want to adjust the friction is in the flow group. And we have the boundary friction here. Let me just bring that up to a 0.3. And also adhesion is an effect that we always see with fluids. I'm just guessing here with parameters. Let's just dial in a little bit of friction and adhesion. And now if we simulate again, we should see a different behavior of our fluid. And you can see now our fluid is tighter, much, much tighter. And we can see we also start to hit now our container here. So we are getting to a point where it actually works. I might even want to increase the friction a little bit, but maybe it's not needed. So we can have that. And we also might want to increase the density of our fluid for now, because it's spreading out a little bit. So I want to have a tighter packed fluid, so like that. So, and now I get a nice flow, compact stream of fluid right into the first chamber. So, but what we have now is, or what needs to be done next is the interaction with our wheel, with our water wheel. Because right now they are just going through. And that is because we don't have the water wheel in any of our setup. So I could be lazy again and just add in the flow boundary the wheel as well. But I don't want to do that because there's many reasons for it. And one reason being I want to show you how cool the OpenVDB is. And with the OpenVDB boundary, I have even more control over what should happen and what shouldn't happen. So the next thing is we need to bring in the wheel for our OpenVDB work or collision detection work. So let me bring in the water wheel. Same deal. I'll just press Shift and move the node down. And I'll just copy the node. I'll remove the selected and I'll pick the water wheel. And the water wheel obviously needs to go into the wheel. And because we are now talking about OpenVDB, which needs surfaces, polygons, and meshes, we have to turn on instance shape. So what we get now is we get the mesh into thinkingParticles for our further processing. So I can hide the original mesh. So now the original water wheel mesh is hidden. And when I restart my simulation, thinkingParticles automatically brings in the mesh. So now I brought in the mesh. And the next thing we need to think about or make sure is, because we're talking physics, we're talking visual effects simulation with fluids interacting with meshes and rigid bodies and all this kind of stuff, we're talking about mass. Like the fluid, it needs a mass. We are also going to create a mass node for our wheel. So that's the thing we have. Now we have a mass for our wheel. And the next thing we need to think about, as I said, the wheel needs now to interact with our fluid. And that means when things interact with each other, fluid has mass, fluid has density, fluid has pressure, and our wheel has mass, our wheel has a rotational momentum, center of mass, and all these kind of freaky stuff, mathematic physics things we need to care about. So the next thing is we need to turn this into a rigid body. And this is done pretty simple and straightforward in thinkingParticles by using bullet physics, or you could also use shape collision and all this. But for the speed and sake for it, I'll just use the bullet physics. And the only thing I need to add now is the BT rigid body, which turns any particle that has a mesh into a rigid body. It does it automatically. And what it means it attaches its parameters. And its parameters means a solver. We can add multiple solvers, have multiple physics solvers. We can have convex hull. Let me just bring convex hull here active. And here comes an important setting you might overlook when you start working with thinkingParticles, because it's so flexible. It allows you to do so many things. So the sleep threshold is a very powerful function in thinkingParticles. It allows you to start at the sleeping or rest state for your rigid body dynamics. So if you stack boxes, if you stack cubes or whatever, you can get them asleep if there's no interaction at the beginning. So they are not considered in the physics. They need to be woken up to interact with other rigid bodies. However, in that case, I don't want the water wheel to sleep, because the water wheel needs to keep on spinning, even if we have a changing pressure amount hitting the water wheel. So make sure we set that to 0, 0. So the last thing missing, I can't select right now, is our physics solver. So to do that, I'll just create a physics solver in the open VDB dynamic set. And I'll tell you in a second why I do that. We could place this bullet physics solver anywhere in our dynamic sets. We could place it in the sim, in the gravity, in the create. Doesn't matter, we can create it anywhere we want. However, I'll tell you in a second when we go deeper why I do it here. But now we have the bullet physics here. The thing for the solver is we need to decide, okay, the solver should work on something, on the particles, and we want the solver to act on the wheel. And then that's actually all we need to set up here. Everything else is default. We don't have to care. We have the physics solver here. So we go back to our create. Remember, we have to specify in the BT rigid body, we have to specify the bullet physics. Now we bring in the water wheel and we assign it to be a rigid body. And while I did the setup, I tricked you, because I first created, remember, the first thing I created was the mass node, and then I created the rigid body node. Have a look in the over here in the tree view. We have our object to particle, I have the mass, and then the BT rigid body. This order is important, and it's logic. So it's not a restriction, it's the real full power you have as an artist to control what happens and when it happens. In this case, we want to assign to the particle, to our water wheel, the mass first before we turn it into a rigid body, because the rigid body needs as a base a mass value. So if I would turn these around, let me just drag and drop this down, we would run into a problem, because the mass would not be there, because the mass would be assigned after the rigid body. So this would not give the correct mass to our rigid body. So because I created the node first as mass and then later the rigid body, I already know, okay, I'm in the right order. But just to tell you, if you're doing total random setups, you might end up messing the order when it is about rigid bodies. Most of the time it doesn't matter, but when it's about rigid bodies, it very well matters which object is hit first, or especially if you have multiple solvers. We will talk about that a little bit later more. So let's get deep into the next dynamic set. So as I mentioned, we have everything set up. Now we can start the simulation and we see, okay, nothing happens. Even I said and I talked about, oh, we have a rigid body and blah, 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 all this stuff. It's still falling through. So why is that? Because we don't have a boundary or anything that tells our fluid that there's resistance or a boundary. So what we are going to do now is we are going to set up our open VDB boundary. And why do I want to have the open VDB boundary? I want to have the open VDB boundary because it gives me more control about multi-physics effects, and we will see that in a second. So I'm going into OpenVDB. So the important part is when you start with OpenVDB, and there's also an order, you always have to work your way from top down. The first thing you do with an OpenVDB setup is create the OpenVDB container node. The OpenVDB container node defines our a volume grid. How many volume grids I want, what's the name of the volume grids, and what type. So in that case, I want to have a distance field. And the distance field is a very powerful feature we are going to use for our fluid rigid body interactions. A distance field gives me the huge advantage that I can detect a collision way before the collision actually happens, because the distance field gives me in space points or grid points that tells me how far am I away from the surface. And that's the beauty of open VDB and volume grids. It's the only way I know in advance I'm in space, 3D space, I'm that far from a surface. So that's what we want. We want to use a distance field in our setup. And then what you always want to do is, I suggest that, is the show VDB, and that's for debugging purpose, because everything is just untangible. These volume fields, are untangible. They are just happening in memory. So to actually visualize what's going on, I always use a show VDB to make sure the things are happening the way I want it. Okay, so the next thing is we want to work with the signed distance field, SDF. So what we want to do is now we want to actually create the distance field. The OpenVDB container only manages the name and type of fields. It does not create any information. It does not create or use any memory at all. So keep that in mind. The OpenVDB container is just to manage your fields. Actually creating data is done with other operators. And we are using, because I'm lazy, I told you before, I'm using the shape to volume, which is a very easy, simple, straightforward, powerful method of creating volume data. So, and for the shape to volume, all we need to do is we need to specify the container. We need to specify where's the volume data. I want to attach the volume data to our wheel, and what field or what volume grid, which volume grid I want to create. And I want to store the data in the distance field. And remember, we create the distance field, or we told our OpenVDB system now, I want a distance field. So let's have a look if we want to adjust anything else. We want to create this field only once because the water wheel doesn't deform. And I only want to have the narrow band, so I don't want to have a really filled deep volume. And let's go through. So now we specified all we need to specify. I say, create me a distance field out of this wheel. We get that here. And create it one time. And maybe I'll go with a raster size of our grid of 2. So that will create our distance field. The next thing I want to do is I want to work with this distance field. And here comes the boundary. So I want to use the boundary, the OpenVDB boundary. Same deal, I need to tell the boundary, use this field from specified by this OpenVDB container. And you get the distance field from the wheel. We want to use the distance field that was created with the shape to volume. So we want to use that as a reference. And I want to affect particles by this field. And the particles I want to affect are the fluid particles. And here comes now the physics effect I want to have with my boundary. I want to have a rigid body void inside interaction. So that's the most important part here. I want to have the rigid void inside interaction. And same deal here. Let's give just for safety measure, let's give a little bit of a margin here, 1.5 maybe. And that's all we need. We get our weight source from the mass of the particle, which is totally fine. So that will give us the interaction. So now if we set up everything right, we will get the interaction. So we have the rigid void inside, we have a little bit of a margin, so everything is set up. So, and here comes the beauty, because we are working with multi-physics. So, and multi-physics simulations are always tricky, because you have fluid simulation, you have a particle simulation, you have fluid boundary, you have a rigid body, you have a open VDB boundary, you have a rigid body open VDB interaction. So we have multiple solvers here at work. And the crazy stuff here is, and I know for you as an artist, it should all work, and why should I care? But still, keep in mind what's going on here. We have multiple solvers fighting each other. So the rigid body needs to handle the rigid bodies. The fluid wants to push them away. The rigid body says, no, you're not pushing my rigid bodies. And the boundary says, no, 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 no. Here's a boundary, rigid body, you have to move now. And the fluid says, oh, I want to penetrate your boundary. And the boundary says, no, fluid, don't do that. And this creates a chain reaction of fluid solving rigid body madness. And we have to make this, that this is all in order. So when we move fluids, we need to make sure that the fluids don't move into rigid bodies or boundaries. And then when the rigid body moves, we need to make sure that they don't move into fluids. And this is why you want to make sure that your boundary activates, so first the boundary, and then it activates the bullet physics. This is how you should set up the whole thing here. And that allows us to have multi-physics simulations. So keep in mind that you set it up that way, and that was the reason why I have the bullet physics solver in my OpenVDB setup. If you remember in the beginning of my presentation, I said there's a reason I put the bullet physics in here. So the only thing left I want to make sure is that our volume data is created so that we have the distance field, and that our boundary will work. So I told you I always create this show VDB. So now I want to visualize my wheel data, my distance field, and I'll just go back and forth. So the first thing I see, okay, all is fine. So now I have a really sigh of relief. I have a volume information, and I can actually visualize. Let me just bring that up again. I can actually visualize the interior of my volume. And you see these red dots. So now my mesh, my surface is voxelized, is created out of voxels. So all the mesh is covered with these red dots in 3D space. So when we go in here and have a look, we will see that we cover the whole volume with these points in space. So each one of these red dots is now representing a point in space inside of our water wheel. And as I mentioned, that's the amazing power of OpenVDB. We turned this wheel now into a volume object. Now we have the huge advantage of telling, let me just show you the vector display, let me just scale up the vectors, where we have, these are the vectors that are created on each position. So that gives us the distance to the surface. Now we can, around the wheel, we can detect how far away are we from the surface. And that's pretty useful, as you can imagine. So I'll turn off. So everything seems to be fine in my setup here. Let me just bring back my water wheel. So everything is seems fine. We have the volume, we have the volume grid. So let's have a look. And I can tell you something crazy will happen right now, but let's just play through. So fluid is coming, and you saw what happened. Let me just repeat again. Let's have a look. Fluid is going, and my wheel is gone. Why is that happening? Remember, we are now in the area of real-world physics. And mass, I was talking so much about the mass is important between objects. Do you remember? What mass did we give our water wheel? We gave it the same because I was lazy. I just copied the mass node. I was lazy. I just gave it the same mass as one water molecule. So this wheel has the weight of one water molecule. Now imagine what happens when 2, 3, 4, or 20 water molecules hit that. It shoots away like crazy. So how about we give it a reasonable amount of mass? So let's say maybe 1,500. So now we have a much, much higher mass than one water molecule. I have to reset the simulation. And now if we play back the simulation, we can see our water wheel is now not shooting away, but it is doing other crazy shit or stuff. So it's going up in the air and it's turning somehow in the wrong direction, and it doesn't look real or doesn't look good. So how do you solve that? You have set up and now you think, oh, I have everything right. What's going on? Why isn't that working? So first, this thing is not fixed in space. We have to work on that later. But there's another issue that is not right for sure in that setup. This is why I keep it free floating right now, because it should not behave like that. When it gets hit by these water particles, it should fall down and not up. And that's because we have to see and have a look what our boundary is telling what to do with the physics simulation. And if we look in the boundary, we can see we have similar, like we had with the fluid boundary up here in the pipe, we have similar settings like friction, adhesion, and buoyancy. And the buoyancy is nonsense in that case because the object is not dipped in a pond or inside of fluid. So this is wrong. So I have to set this to 0. I'll reset the simulation, and now if we have a look, we see, okay, now it's behaving as we expect. Water is falling down and the wheel is going down and it's not floating up. It still moves away. So we have to fix that. So how can we fix fix our water wheel in space where it should be, in the center of mass? So we do that with a joint. So we need to joint now this water wheel, and there's also a really easy, simple, straightforward solution. And because I'm lazy, I'm going to use this solution to create our visual effect. So let me create a joint. So what that means is we have in Thinking Particles, we do a lot of work for you, the artist. So there's a lot of things going on behind the doors. And you need to know that or be aware of it. And we have this function in the object to particle that automatically grabs joints that are attached to meshes or objects in 3D Studio Max. And I'm using this function because I'm lazy and I want to have fast results. So what I'm doing is I'm telling this object to particle that brings in our water wheel, use a bullet physics solver to create joints or find your joints. So that's all I need to do. Keep that in mind. In the object to particle down there, under the joints rollout menu, you sometimes overlook it. you choose your bullet physics solver, and that's all you need to do. Now, when I attach a joint in the 3D Studio Max world, it will automatically grab this joint and use it. So how do I get now the joint going? So for now, I'll just move this out of the way, and let's create a joint. So what I'm doing now is creating a joint. And this is found in the helper section. TP helper, thinkingParticles has these helpers in 3D Studio Max, and there's the TP joint bullet physics. So what I'm doing now is I'll just create the joint here. So now I've created a joint. So I just clicked it in space here, up here. And this joint, I want to act as a hinge. Not as a point joint, I want a hinge. So the hinge has a huge advantage that it's fixed at one point and is freely rotatable around this point. So I'll choose the hinge as an option, and I want to have this joint attached or connected to our water wheel. And now don't do the mistake and click the water wheel here, because what you're seeing here is not the water wheel, it's the thinkingParticles system. So what you need to do is click the water wheel. If we would have clicked the water wheel we see here, we would connect to thinkingParticles, and that's just a dumb helper that wouldn't help us anyway, and it would not work at all. So what I did is I clicked the water wheel here because it's right now hidden. I can unhide it and bring it back, but I can also click here. So I bring in this, and now I can say, okay, choose the position from my from object. It jumps right in here. And just for the sake of it, let me make this bigger, 120. And I can also align it along the from. So it's now aligned to our water wheel. But when you look carefully, you see this red disc. The red disc is my rotational, my free rotational axis or plane. So, and right now that would be really shitty because the water wheel would spin around its vertical axis, and that's not what we want. So the water wheel would spin around here. That's stupid. We want to spin it around its axis around here. So what we need to achieve now is somehow change the alignment or rotation. And the easiest and best option is to just grab the joint and rotate the joint by 90 degrees. So let's be accurate, or this will start wobbling. So now, as you can see, our disk, our visualization of the hinge is exactly aligning with the rotational direction I want to have for my object. So why do I need to care about this? Imagine this water wheel could be anything. Could be a spaceship, could be a robot, could be a finger of a robot, could be a spine, could be a mixer, whatever. So it is not clear which is the rotational axis. So this is why you need to think along, and that's also why we say our product is named thinkingParticles, because you have to think as well. So now we have aligned our rotational axis. All is fine. Let me bring back my setup. So what we have here now is we have our joint assigned. We have it assigned to the water wheel. And the most important part in the object to particle, when we bring in the mesh, we tell it, hey, grab everything you see as a bullet physics joint, grab it. So the only thing we need to do is go 1 and back to frame 0. Now the simulation has been recalculated. We grab the mesh again, we see, oh, there's a joint attached. We grab the joint, and bullet physics automatically knows I need to use this joint for any physics simulation. And now let's have a look if it actually works the way we want to have it. So now we fill the stuff and we see, okay, it is rotating and it's kind of working. Our water wheel is rotating, but there's still some other stuff going on and happening. Let me just play this back. But you can see now it is kind of working as we want it to work. We still have a little bit of an offset there, so we need to make sure that all is properly set up. We get the bullet physics in here. We say, okay, we want to have the rigid body, all is assigned here. Then we go in here, we make sure that our boundary is properly, we have the bullet physics set up, we have the wheel in there, we have the mesh. And the next thing we need to make sure is, so that our systems work, is we need to make sure that our simulation is actually properly set up. And right now we were working in full frame simulation, and full frame simulation is a little bit critical for physics simulation. So what we have to give it at least is a half frame simulation step. So now we have to work in half frame simulation steps to get the fluid simulation better, more accurate, and to get the rigid body collisions more accurate and working properly. So, and now we are going to do that just right here, and we are going to have our fluid simulation here now working properly. So, and as you can see here, now we have the setup we are after, and we can see to enhance it and to have it a little bit better. And we are doing some tweaks to the simulation. But what you saw here, just by going from a per frame, I know it's very tempting to do simulations per frame. I'm also a per frame step simulation person, but that's not really working, as you can see here. It's way too inaccurate. With our high gravity amounts, the particles are so fast that they just traverse the volume and they are gone. So we at least need to be half frame simulation. And with a half frame simulation, you already see that our fluid also now works much, much better. We get a really dense stream of particles. We get the nice splash of fluid here, and everything is working as we expected. So the next thing is to fine tune. We could work a little bit on the fluid simulation. So I don't like now that the fluid is way too dense. So what we are going to do, I had to reduce the density a little bit because we only had frame steps. So I'm giving the fluid a little bit more pressure, so it's a little bit more loose and lifelike here. And it gives us more pressure. And we also, I'll reduce the surface tension and maybe give it a little bit more viscosity so that we don't have to work. So now we have the fluid in a way, I like it. The only thing I don't like right now is when you look closely with the first impact, our wheel already starts or nearly starts immediately to turn. So I would like to just maybe increase the mass a little bit more. Let's try 4,000. And once more, you have to be careful. We are now in the real world with rigid body dynamics, working with real values and parameters, and we might have to give our particles also some, because you can see when it is filled, it nicely moves out of our container here in the water wheel, but it slides like it's on ice. And that's what I said we have in the boundary. We have much better control on the boundary friction. So we can increase the friction. Let me increase the friction. And we can increase the adhesion as well to a much stronger. And the cool thing is, because we have a distance field, we can grab particles even when they are a little bit above the surface. So now let's have a look. When the fluid is there, we have now adhesion, we have friction, and now it looks much more better what we have here. So we have the wheel set up now, and let me just bring in my final scene so that you see when we set it up, because I spent over an hour now, and let me just bring in the final setup here. So it's the same setup, but in this setup, I added something as well. I added a hydro field, which is just a plane down here, and I turned this plane into a hydro field. And with this plane, you will see in a second what happens. With this plane, I have interaction with the water wheel, and also, I have a higher resolution here right now. So what you still see here is real-time simulation. So now I fill the water wheel in a much higher amount of water here. And now the water splashes down here. And as you can see down here, let me just show you the surface. You see that the surface is deforming here right now. So as the water splashes into the pond, we get the interaction with the fluid. So here it gets even crazier. We have multiphysics up here, as I told you. We have multiphysics with OpenVDB, a volumetric interaction, rigid body, fluid simulation. And down here, we have the same deal. We have OpenVDB, a rigid body, and a hydro field simulation. The hydro field usually has nothing to do with fluid dynamics. So we can get the fluid into our hydro field dynamics to create a multi-physics simulation that will have proper interaction between rigid bodies, between another fluid simulation, and look at the speed we can create and simulate our fluid. This is a live simulation. I'm doing the live streaming, I'm doing my sound recording, I'm doing the recording and everything at the same time on the same machine. This is the fastest fluid you can get here. And even if we wanted to overdo it, we can just go into our Thinking Particles setup. Let me just bring up my Thinking Particles setup. The same setup as you've seen from my water wheel we just did in this hour. I added, the only thing I did here, I added some friction. We have a friction, rotational friction to the wheel, a constant rotational friction. And then in my simulation setup, the same deal. The only thing I added here was the hydro field. I picked the pond, it's a plane object, and I'll set up the hydro field to react on our fluid. And that's it, that's it. And the same deal here with the OpenVDB, bullet physics. And now I also prepared the surface. So if we wanted, we can visualize the surface. However, the surfacer, if you want to have a clean, nice, smooth surface, the surfacer will take a little bit of time to create the surface. Let me just zoom in a little bit with the surface. Okay, let's turn this into, so we now created the surface. So with every step, we now actually also get a surface here created. And let me just zoom in. So you see the surface here. We could also adjust the surface really, really nice. So if I wanted just to have a better connection between all these little droplets, I like the droplets. I don't want them to be that blobby, but again, you can adjust here, do the resimulations, and then you get real nice water sheets. And if we wanted to go really crazy, we can just use GPU ray tracing and go into the 3D Studio Max viewport and have GPU ray tracing here as well. Let me just go back into the physical camera because we have a physical accurate renderer, and then we can have physically accurate GPU rendering in here with everything, reflections, refractions, and just everything in here. Let's just move one more step further, and for that, let's just turn off our particle display, turn off the dots, and here we go. Here we have our water in real time, so we can move forward with the simulation, and we will get the simulation. And if I'm brave, I can also play the play button, but that might end in a crash. So that concludes, I think, our live session here. And I hope you found this live webinar really interesting, and I hope you enjoyed how to create and set up these systems. And I hope you can work along with the tutorial we have here.
Thank you, Edwin. Thank you so much. I just wanted to thank you. What a great demo and what a great storyteller you are. I think everybody enjoyed the dramatization, and you know, we could almost hear rigid bodies and fluids talk to each other.
Yeah.
So it was really entertaining. I do have to apologize because I heard some of the people that meant to attend were locked out. So the first 16 people were able to go in, and there's an issue with the platform. So luckily we are recording everything, so we will post it on